In this video, I'll demonstrate how to find the derivatives of trigonometric functions. I have 4 examples set out for you, and these are the rules for finding the derivative of trigonometric functions. We'll start off with question number 1. Here we are asked to find the derivative of this function, and we will use the product rule for this. This term is made up of 2 separate pieces. That being said, we'll start off by finding the derivative of x to the power of 5, and that is 4x to the power of 4, leave sine x the way it is, plus, we'll leave that the way it is, and find the derivative of sine x, which is equal to cosine x, which is conveniently stated right there. Next, we will find the derivative of this term, and the derivative of that term is minus 3 cosine x becomes negative sine x, plus 10x becomes 10. We're going to further simplify this line. 4x to the power of 4 sine x plus x to the power of 5 cosine x plus 3 sine x plus 10. Let's move on to question number 2. This time we will use the quotient rule for this example. The way you use the quotient rule is the following. You will square the bottom over, so we'll find the derivative of this and multiply it to the denominator. The derivative of this is equal to cosine x multiply to that, and then subtract this to the derivative of this multiplied to the way that is. Let me show you. 1 minus sine x multiplied to that in its native form. 1 plus sine x. Now don't forget, the denominator needs to also be squared. Part of the quotient rule. We're going to multiply this out and see what happens. Cosine x times x. Cosine x times cosine x is equal to cosine x. And then we're going to multiply all this out. 1 times 1, 1 times sine x. This times that. And then this times that is equal to sine 2x. Now don't forget this minus. This will change everything. That becomes minus, this becomes minus, this becomes plus, and this also becomes plus. And at the bottom, it stays the way it is. Now, let's see if we can cancel anything out. You'll notice that this term and this term can be canceled out. Also, you'll notice that this and this is a trigonometric identity. Remember, cosine to the power of 2x plus sine 2x is equal to 1. So we can replace that with 1. Let's do that in the next line. X cosine x plus 1 minus 1 over x plus cosine x squared. You can cancel these two out, and you're left with your final answer as x times cosine x over x plus cosine x to the power of 2. Let's move on to question number 3. In question number 3, they ask us to find the derivative of tangent. Tangent is defined as sine x over cosine x. So instead of using tangent, we can use this. And then once again, we have to use the quotient rule like we did in the previous example. Quotient rule involves taking the square of that and then finding the derivative of this, which is cosine x times that, minus the derivative of this, which is negative sine, times that. And if we continue to simplify this, we end up with cosine squared, these two multiplied, sine squared, which is equal to positive sine squared x. And at the bottom, we have cosine squared x. Now recall that this is an identity. That is equal to 1, as defined above. 1 over cosine squared x. In addition, our answer is also an identity. 1 over cosine squared x is equal to 1 over secant squared x. That is a reciprocal function. So there you have it. That is how to find the derivative of trigonometric functions. In our next video, I'll show you how to find the derivatives of reciprocal trigonometric functions. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.